Good morning, everyone. I hope everyone is doing well this wonderful morning. And I would like to wish you all World Water Day. And today's World Water Day has been organized by Universal Society of Food and Nutrition USFN and scientific partner BioLeaks Worldwide. It is my pleasure to welcome you all to this World Water Day. And I'm hoping that today every one of us gets a lot of awareness about water and we are able to do our contribution to the world. To start off World Water Day, I want to share a small fact with you so that you understand the kind of importance that our webinar would be making today. By 2025, half the world's people will live in high water stress levels places. As in, the water stress that is there, as in the shortage of water, scarcity of water would be very high by 2025, and people will live in those kinds of places with those kind of stress levels. Now, we know how much water is essential to everyday life and how we use it for everything. On that note, I would like to start today's webinar and give all of you a warm welcome for today. Now, a few words about our scientific partner. BioLinks Worldwide is a non-profit, is a globally recognized professional association that operates under the Technorite Group. It serves to propel and fuel all innovative works of research with immense potential in the fields of healthcare, life sciences, pharmaceutical sciences, and the medical sciences in general. In this capacity, BioLeaks Worldwide has been directly responsible for a significant amount of the revolutionary developments that has taken place in these fields over the past few decades. I would like to thank the organizer as well as a few words about our other organizer, Universal Society of Food and Nutrition, known as USFN, is one of the world's largest non-profitable professional associations meant for research and development in the field of food science and technology. USFN is a paramount body which has brought technical revolution and sustainable development in the field of food science and technology. USFN is a forum where innovations and research interests could be supported and developed, prioritizing our mutual interest. Our forums and associates constitutes of professional leaders, universities, organizations, and associations, connecting each other with a mission to work as wizards of science for defending the earth. World Water Day is being celebrated on 22nd March, is an annual observance by the United Nations. It celebrates water and it wants to raise awareness for humanity's need for access to safe water. This year, the theme is Groundwater, making the invisible visible. Universal Society of Food and Nutrition USFN has organized this free webinar session to inspire action towards United Nations Sustainable Development Goal number 6, which is water and sanitation for all by 2030. From this, we are able to understand just how important it is to understand that water is very essential to us and how everyone needs to have access to clean drinking as well as usable water. USFN aims to educate our society about the importance of this water conservation, water management, and future technology related to water sustainability. Together, let us strive to improve the awareness on water management. On that note, I'm sure everybody is being able to understand why we have been gathered here today, and our main focus of today is to learn about water awareness. On that note, I would like to welcome all our dignitaries, students, participants, and our wonderful audience today to this session. We have three distinguished keynote speakers that would be joining us today. So, the first speaker is Dr. Karthik Pothiyappan. He is currently working as an associate professor, Department of Food and Technology, Karpagam Academy of Higher Education, Coimbatore, Tamil Nadu, India. Dr. Karthik Pothiyappan, I would like to welcome you to our session, and we hope that your session will be informative and knowledgeable to all of us. Sir, the floor is all yours. Thank you. Doctor, we are all ready for you. If you'd like to go ahead.
Good morning, everyone. Can you hear my voice? Is it audible?
Yes, Doctor, it is. And
Thank you.
if we could have a quick thumbs up on the chat so that everyone, we are on the same page. Is Doctor's voice audible for everyone? A quick thumbs up on the chat, please. Okay, Doctor, I think everyone is audible, is able to hear you, so you can go ahead.
Thank you very much for inviting me this wonderful event on the occasion of World Water Day. So I'm very glad to share all my research, whatever. So already has given enough information about the why we are conducting this World Water Day. And here I'm going to tell about the nanotechnology from agro to food processing. So where the water is main we are using. Here we are going to deal about from farm to plate. So first of all, I just wanted to give a brief about the nanotechnology a little bit. We'll see about the nanotechnology is we can consider like a 1 nanometer particle. It is equal to 10⁹ meter sized particle. And we maybe think many people we will still think that nanotechnology is something new. It is not actually new. Here, whatever it's present like DNA, amino acids, sugars, and hormones, these are the things are in the nano. Okay. In 1959, Richard Feynman, like a first time he proposed a concept of nanostructure, and he said that there is a plenty of rooms at the bottom. Okay. In 1974, Nario Tinguiche, he just coined the word nanotechnology. So what they are saying, when we are reducing the size of the particle, or when you are going beyond the limit, so what will happen? The surface to volume ratio, actually the mass ratio is increasing. So that is the concept behind this nanotechnology. And we here, when we are going for that, we will be dealing with the production, processing, and application of materials with the sizes less than 1000 nanometer. And this nanoparticle can be based on the preparation methodology. It can be a nanometer or micrometer level. So a simple example, we'll see about the nanoscale. We just take an example of a watermelon. It is a 10 centimeter. If it is reduced, it's like a coin 1 centimeter. If it goes to our red blood cell, it's 5 micrometer. Whereas our hair, it is 100 micrometer. And the water molecule, 0.1 nanometer. So the nano is everywhere in our lifestyle. So it was there. So it is not a new to our entity. So this is the basic mechanism which we will be using for the nanotechnology. So one is a top-down approach and bottom-up approach. It is a top-down approach, means from the bigger particle we can reduce and we can bring down to the nanometer scale, like a 1 micrometer to 1 nanometer. Whereas if you see some atoms or molecules, it is below nanometer. So those things has to be bring over to the nanometer. For that we will be using nanoprecipitation, inclusion complex, some of the technology. It is a top-down approach, nano encapsulation, emulsification, such kind of techniques. So the commercial products in nanotechnology, the nanotechnology is the multidisciplinary aspects where every places are all the field we will be using. For example, automotive, cross-cutting, and food and beverages, good for children, for so many things, are toys and everything will be using the nanotechnology. But among these, the health and fitness, it shows n number of products. It shows the future of nanotechnology in the health aspect. Next, the overview of nanotechnology in Agri-Food sector. Here, the nanotechnology first it plays the agriculture, then it goes to food processing, then after the processing will be going for the food packaging, finally the supplements. The agriculture, you can see about the nano capsule. So here nano capsule, nano sensor, nano chips, these things are using to monitor the growth and the enhance the agriculture field. Next, after the agriculture, we are taking the product, then we are going for the food processing. There we will be preparing nano encapsulation, nanoparticles and emulsion gels. Those things can be prepared in the food processing. Where is the food packaging? We need to deliver the product one place to another place and need to extend the shelf life. So what we can do, they will be using the biodegradable packaging material and nanoparticles, and even we can also use nano sensors. So these nano sensors, we can find out whether the product is safe or degraded or any other spoilages occurred. Those things can be identified. Then final one is supplements. The food, whatever we are eating, whether it is delivered in our body, it is not or not. So those things has been find out through the supplements. Through that we are using the nano encapsulation, nano chelates and vitamin sprays. Those are the things are recently developed based on the nanotechnology. In nanotechnology agriculture, we will be using the nano fertilizer. We will be effectively using here. When we are going for the nano fertilizer, we can reduce the pollution and favorable to the environment. It won't spoil the water or the soil and then whatever the living good organisms. So those things will be preserved, and then we can also get the increasing yield. So the important things we can see in the fertilizer, we know that the nitrogen is playing a major role because it gives the vital structure to the plant, and then also gives the proteins and enzyme chlorophyll, and for the nucleic acids development and hormone growth. All those things, the nitrogen is important. All those also the nitrogen is asked through the process. What are the process they are doing? The denitrification, ammonia valorization, environmental pollution. Because of these things, the nitrogen is getting lost, and then we'll be introducing a nano urea fertilizer. Through that, what we can do, boosting nutrients uptake and nutrients use efficiency, and reducing losses via leaching, and higher productivity and economic turnouts. So from nano urea we can introduce, and these are the nano urea already is available in India. Actually, the first time in the world, IFFCO, NBRC, Gujarat, they have patent. In India, they have done it. Through that, the farmers are getting benefited. This nano urea has given a good reputation and good yield. And farmers, almost 11,000 farmers field trial, and they have done it, and 9 acres under in the Krishi Vigyan Kendras they have done, and they have got good result. Next one is nano food processing. In that, like we know that 60 years before, the population in the world, or if we consider in India, it is very, very less. But now at the present situation, the population in India is 138 crore. Okay, so how to meet the food security, and how to give the food safe way, and how to feed the food without hunger, and nutritive food is much important. For that, we need some industrial revolution in food sectors. For that, I can propose here the food ingredients converted as a nano. So through that, when we are converting as a nanotechnology, we can increase the surface area of that particular compound and improve the bioavailability, like vitamins, minerals, enhance solubility, and we can also do the controlled release, whether doing through flavoring agents, and we can also use the chewing gums as gels. And by using this micronutrient directly, if you take, what will happen through the when it goes through the our industrial system or oral process, and it goes to the go the small industrial system, what will happen due to the pH changes, acidic conditions, the nutrients will get spoiled and it will get degraded. So this nanotechnology can take the bioactive compound and deliver into the gastrointestinal system with more absorption. And what can be the bioactive food compound? Which one we can be encapsulate? Like the encapsulation can be done with the very sensitive food ingredients, like the fish oil. It contains DHA, EPA, and vitamins like vitamin C, vitamin B1, B2, like that. And where is the bioactive polysaccharides like lentinan, and minerals phosphorus, iron, magnesium, and well is the polyphenols like anthocyanin and resveratrol extracted from the grape and curcumin extracted from the turmeric. Those things can be encapsulated. And any product or any company you wanted to start, you need to know the world market. So what is the market in the world market in nano food? They have given here. Yeah, they given the Helmuth Kaiser consultancy in 2004. They given the 2.6 US billion. Whereas in 2020, the growth they have predicted almost 20.4 US billion. So you can see the bright future about the nanotechnology by seeing their the Helmuth Kaiser consultancy report. So with that, we can say that nanotechnology have a bright future. We can do it with a full energetic way. And what is nano encapsulation? It's a nano encapsulation. It means the core material can be a nutritive or bioactive compound, or nutraceutical compounds, or functional food. It will be in the core material. It will be the middle. Around that there is a capsule is formed that is called encapsulated material, that can be a biopolymer or the protecting agent, you can say. So it will create, it's give us a capsule. Inside there will be multiple core or a single core. Core means it's a bioactive compound may present. When you make this encapsulation, we can increase the stability and to mask the core material, and also we can increase the handling and the transport property. Suppose if you are in the oil state, you wanted to transfer from India to other country, foreign nations, we want to transport, we need a big container, very big container we record. So when you are converters the nano encapsulation, then what we can do, you can just pack that one within the powder range, the powder, and then we can convert very easily. Then it is also controlled under target release, where you want to release in this compound, whether you want to release in small intestine, or you want to release in the mouth, or where you want to deliver. So those things we can be done by this encapsulation, and also we can product from the environment. So this can be a different shape, like one monolayer will be covered with the capsule, or multi-core layer will be covered, or n number of bioactive compound can be keep it within the system. So those things can be done it. And what are the different types of technology is available for making the nano food system? Like we can see there's like a spray drying, freeze drying, and post-version electro spray. So many techniques are there. So we will be seeing here very few techniques we can see in that presentation. And here we will be see first the liquid based nano delivery system. Like what will be, why you are first you are focused on liquid. Suppose we wanted to take this nano supplements through the milk or beverages, what we can do, we will be doing the emulsion. For example, the most of the yogurt will be there. In the yogurt, you can see that the nano encapsulated particle will be dispersed in the liquid system. Whereas if this liquid system, if you wanted to put it in the powder based material, then what will happen, that due to the water activity, it will spoil very easily. So we need to design our food based on the material, which material you are going to use, which product you are going to use. Those things are much important. And this is the first, we will deal about the nano emulsions. And here in the nano emulsion, what will happen, the oil droplets is dispersed in the water system. Okay. So the dispersed in the water system within the nano range. To maintain the stability, we'll be using as an emulsifier. In that emulsifier, it contains hydrophilic region and a hydrophobic region. Where is the hydrophilic? It's a oil loving portion where it is stick with the oil pot. Where is the hydrophobic? It is a water loving portion. It will be stick in the water. It's create as a spherical form. By making this nano emulsion, we can improve the stability, and we can also make it as a nano encapsulation by using this methodology. And next, the type of nano emulsion, it will be single emulsion, multiple emulsion. For the single emulsion, oil in water emulsion, various oil droplets dispersed in the water. For a best example, milk, whatever the milk is, we can consider as a natural emulsion. Whereas the next one, water and oil emulsion, where the water droplets is dispersed in the oil. The best example is moisturized cream, So that is the another kind of emulsion. Then multiple emulsion. Multiple emulsion means oil, water in oil. So oil is dispersed in the water. Water is this system is this. Homogenization, and finally we can bring the nano emulsion. So after the preparation of emulsion, you can see the right side microscopic view. Here we can see the droplets is uniformly distributed, and it will give the more stability. Next, another things, if you consider like a green tea nano emulsion. For example, if you drink a green tea, people are more people nowadays started to drink a green tea. But we will be drinking, and we see that when you drink the green tea, we will be getting more like nutrients, and we can reduce our body weight. Like so many things already is available, and we used to see. But actually, when you drink, you are not getting 100% absorption, and there is a poor chemical stability and low oral bioavailability of limits, and it extends metabolism under rapid exhaustion. So it is not absorbs exactly. When you pass through our mouth, when you are drink the tea, when you pass through, it reaches to the stomach and the small intestine. Through this, what will happen? The pH and the acidity, the green tea, it will be degrade. There is a like the metabolism is not taking a place properly. So what will happen when you convert as a nano emulsion form by we are using the soy protein, we are preparing an emulsion. Then we also tested by the animal study. When we are doing this study, we got 2.78 fold increase the bioavailability and bioaccessibility when compared to without making a nano emulsified green tea. And also it is increased the intestinal permeability of the green tea catechins. So that there is the another things like we also did the nano emulsion by using the orange flavor oil. Somebody wanted to drink a flavor beverages, and that beverage it has to, when it goes to our tongue, what will happen? Suppose we are using the like some flavor, you wanted to deliver that flavor in your mouth. So what kind of medium can be used when it has to be released? Because when you are drinking the juice, it will be stay very limited time in our mouth. Okay, for that we used starch based and protein based emulsifier, and then we have kept it for our mouth, and it will like very less than 3 seconds, or we are also considered 10 seconds or 60 seconds how the flavor releases takes place. But when we are using the starch as a emulsifier, it is reacted with our oral saliva. The saliva is presented alpha amylase. That alpha amylase, it's like interact with the starch, and the flavor is released immediately. Whereas the protein, if you are using it won't digest in our mouth. It is goes to the stomach. In there, with available stomach juices like acid conditions and juices, what will happen? It will deliver. So these everything is based on the material what we are using. So through these techniques, we can say that when you are using as a starch for preparation of beverages, then we can definitely deliver our orange oil. Next one is when it goes to small intestine, what will happen? So those things is much important. Here we have taken for the triglyceride oil, we have taken it is goes to the stomach. When it goes to stomach, and slowly the digestion takes place. As those things we have studied. When it goes to stomach, you can see this monoacyl glyceride and 2 fatty acids. Those things can be presented. Next, you can also, we also studied about the morphology of the particular droplets. When it goes to stomach, every 30 minutes, 60 minutes, how the digestion takes place. So for that, we used confocal laser scanning microscope, and we have collect the pictures, and we studied. And here we can see that the protein-based emulsifier, it's delivering the bioactive compound very effectively when compared to soy lecithin, and twin 40 there is another emulsifier, and we have got a very good result. Next one is emulsion gels. So emulsion gel is structurally soft like materials, and the scientists are more interested in emulsion gels due to the slow release of lipophilic flavor compounds like effective delivery of carotenoids, vitamins, minerals, and other functional compounds. Because when you are chewing the gels, the bioactive compounds slowly it is released. So those things has been studied. Next one is another one is the Nano Liposome. In that, we are also using the phospholipid molecules. So two lipid molecules we are using to create a structure within the liquid state, and inside we are giving the bioactive compound, and we will be releasing. Through that, we can also this methodology can be implemented in the food and beverages industry and dairy products, and we can also use a food fortification in dairy, beverages, and nutraceutical functional food, and so on. Next one is another study, the solid lipid nanoparticle. This is now people are started to use, and here you can see the curcumin. Curcumin we are extracting from the turmeric. If you are taking the curcumin directly, if you give the through oral, there is a poor absorption, and whereas when it converts the solid lipid nanoparticle, this system here what they have done, the lipid layer will be in solid. Inside the lipid will be the solid place, and outside we'll be using the emulsifier. It's a phospholipids, and when it's converted, the absorption kinetics are very high. Enhanced intestinal absorption we could able to achieve. Then the nano delivery in solid system, like if you in the tablet form, what are the technologies available? You can see the spray drying technology. This technology is 1965. It has been patented, and people are widely using. And the first Amul powder, you may be knowing Amul milk powder. It is sprayed by CFTRI, and this is the one of the technology. Next one is this is the spray dry. So this is the spray drying techniques. They will be using like the feed material will be given in the top, and then we will be using the hot medium. From there, the water particles evaporate, and we can get the powder form from the product collection cyclo chamber. And this is the capsulation form. The flavor will be capsulated in the vacuole, you can see. And here we have done the orange oil. And then we can see that when doing this in 30%, and we also did the fish oil or like algal oil. Through that, we can able to maintain the shelf life of the fish oil. And another one is the nano spray drying. With the concept of this micro encapsulation spray drying, we have prepared the nano encapsulation. Here, instead of the spray nozzle, we will be using piezoelectric actuator. From that, we are spraying the particle, and through the charge, we are collecting the particle. Next, another one is the freeze drying. The freeze drying, the high sensitive product, we can make an encapsulation by using under low temperature, and I mean minus 40 degrees centigrade, and low pressure. We can make a encapsulation. Through that, we can do the probiotic cells and omega-3 fatty acids successfully we have done, and we have got high efficiency. And next one is spray freeze drying. This is another techniques. During my research, we have done it. We have combined spray drying and freeze drying, and with that, because the spray drying we may be knowing, we will be using the heat, so the sensitive food ingredients will get some issue. Where the freeze drying, it is a cost effective because it takes 24 hours to get a dry. So this technology we have done it in a CSIR, Central Food Technology Research Institute, the help of Dr. C. Anandramagishnan, who is the director of NIPTM right now. So with that, we have done it. With that, we can do the encapsulation minus 196, and one or 2 hours is sufficient to do the drying. With that, we have done it the fish oil and vanillin flavor, and we have got very good encapsulated powder. And another one is electro spinning. It is like we used that syringe. We will be playing with the voltage. We will be giving the positive voltage in the syringe needle, and the collector we given the negative. When the voltage is applied very high, what will happen? You will get the spinning. So through the spinning, we can't get the encapsulation. By through this methodology, we can't get the encapsulation of bioactive compounds, and packaging material can be used, and the nano biosensor, all those things can be done it. And next one is electro spraying. The same techniques, instead of giving the higher voltage, when you are tuned the voltage, you will get the spray. So you will get the individual particle. Instead of spinning, you will get the particle. So that one we have prepared, and we are through that what we have done it, curcumin and resveratrol. We both compound we have taken, and after the prepared, we are also used the 3D printer, and we just they have prepared the butterfly shape. In the butterfly shape, they can enrich, and we can give like children and all, they like such kind of image is there is created the food. Then we can we can also like, and even children's love more. So this is another technology, and we also prepared and extracted the bioactive compounds, and we prepare an emulsion, and we given the incorporate the yogurt. That yogurt we given the animal, and through that we also got the higher bioactivity. And these are the common encapsulating wall material can be used, like gums, carbohydrates, lipids, proteins, and those all the things can be used, and means emulsifier, or the covering material can be used by using organic material, lipids, cellulose, all those things. And the application wise, if you see, it just gives a high powder yield and hygroscopic nature product you can be done, and encapsulation efficiency is more, and more cell viability and stability against environmental parameters. Okay, then so here so far we have seen about how we are preparing from farm to the processing, and next we have to go to the supplements. So what are the product is available in the market? You just see that there is one product like a tip top omega-3 bread. This is available in Australian market. What they have done, they just encapsulate in the fish oil and then enriched. And next another one is the water system. Like the water, they have, if you put any particle, if it is float or if it is settle, we don't drink the water. But in this nanotechnology, they have made it as a minerals become encapsulation form, and they have put it in the water. You can see the translucent effect. So, and also we can increase the bioavailability 4 times and better absorption. So this things is available in the German. Next one is nano tea, and this nano tea it was available in China. And when you are preparing a nano tea, and the absorption is 10 times is better, they have given. So these are the things they reported. And next one is nano put in the market like a canola oil. So we know that if you take a oil, it is like people mostly avoid to take oil because they feel like it will create obesity and weight and gaining the weight, all those things they will be saying. But in this oil, particularly so this product is available in the market. So this is the beauty of nanotechnology. You can see how the oil is reduce the cholesterol level. Next one is the soft gel. You can also use the lycopene and the spray like if you want a vitamin, just spray in your mouth, you will get the vitamin B12. Next one is already available is Horlicks. Horlicks, they are saying like a DHA enriched Horlicks. They say the mother Horlicks. Why they say that the mother Horlicks they call? So when the woman is get pregnant, and then after the 4th month, when the neurons and everything start functioning and they start development, at the time we need to give the good supplements. That is the supplements we are giving the from the DHA. So that DHA cannot give directly. So what they have to do, they have to do the encapsulation form. So those things has been done it in the Horlicks, and this is successful in the market. Next, people always say, some people it's like a nano food, no. So is there any like issue when you are going for the nano? So for that, they given the Institute of Food Science and Technology in 2006, they mentioned size matters. Means like in the label, you have to mention the size. So that is much important. The another one is the government should consider appropriate labeling and make regulations. That is much important. And then FDA, they're not given any like a mandate labeling, like a nanoscale and regulation. They are not made it anything. Whereas the engineered nanometers will be clearly indicated in the list of ingredients, and names shall be followed by the word. This is given by the European Food Safety Authority. They given like if any food it is the nano, we have to give the word nano. So that has to be mentioned. So, and one more thing I can say, if any product in the within the less than 100 nanometer cannot be accepted, because if it is take that kind of nanoparticles, it may go to the our blood brain barrier, and it may be causes death also. So we should not go majorly less than 100 nanometer. We should go above 100 nanometer. That would be safe. And the future concluding, we can say the considering a choice, we can prepare as a nano encapsulation by playing a different kind of wall material, and from this we can also deliver controlled or quick flavor release or bioactive compounds through oral or in the intestine or stomach, wherever you wanted to deliver. And the nanotechnology has begun to find a potential application in the area of functional food by engineering biological molecules towards the function. And we can also design our own food, the based on the like the dream food. Also, you can say the dream food. Whatever you dream, whatever you wanted to have, you can prepare by with the desired flavor and color and nutrition. So this is a very promising technology can be adopted. I would like to say the acknowledgement. Dr. C. Anandamakrishnan is my guide, and he presently is an director in NIPTM. And Professor Jian Chen is also director, and is from China, and Professor Amail Italia is University of Leeds, UK. And next, my institute, Karpagam Academy of Higher Education. For then, finally, I thankful to the Universal Society of Food and Beverages and the organizing committee and chairman, and the special thanks to Mr. Hariharan. He's keep on contacting me, and he arranged a wonderful webinar. And these are the collaboration work I have done with various institute and even foreign I am doing. And if you have any queries and you can contact through any other mode, thank you. If you want to discuss, you have any queries, please discuss. I'm very happy to answer. Thank you.
Thank you so much, Doctor. That was a very wonderful and informative session. We are so happy we have been a part of that session. Now, we would like to take a few minutes to take any queries or any doubts or any clarifications that any of you would require. You can verbally ask it out to the doctor, or you could even post it in the chat box so that we can address it. We'll take a few minutes for this Q&A. The floor is open to questions. You could even post it in the chat box as well, type it.
Yes, let me ask some question then.
Yes.
Hi, Dr.
Yes,
Kat.
doctor, you can go
Yeah,
ahead.
very informative session, sir. Thank you very much for your information. I have just I'm not from the food science like technology field, so I'm just thinking that if we go towards the nanotechnology into like development in food science, do you think it's gonna for a long term, let's say for the next 50 years or something like that? Do you think it's gonna affect like human bodies like at some stage, or some change is gonna be with the human health, or it will bring up only the good or positive like impact?
Yeah. Thank you. It's very interesting question. Yeah. Whenever you think about the nano, the size is a matter. So that we have to think about it. So what your concern is 100% correct. When you are taking a very small particle, there is some leaching, or there is some migration from the packaging material or some outside to inside, and it maybe go to our human body. So that is your concern. I understand, but we need to consider the size, because for the food materials, the size is very much important. You have to consider where is the material science or automotive or mechanical engineering or electrical. There is the size is not an issue because we are not going to eat. But in the food, when we are going for the size less than 100 nanometer, we no need to think about the particle hazardous. It won't affect our human body. So when we are planning to prepare the nano encapsulation or nanoparticle, it should be above 100 nanometer. If it is above 100 nanometer, it's very safe. Okay. So that is the things already in UK Parliament. This kind of argument was going on almost 15 days. It was going on whether can we allow this nano food to the market, like a GMO. We have a question in genetically modified food. So can we make it as a GMO? Because GMO, a lot of problem is now we are facing, but still how it is migrated. But nano also will have such kind of things like that. They have the discussion, and finally the UK Parliament come to the conclusion like if it is above 100 nanometer, it is safe for the human. So that is the one I can tell you, sir. Thank you.
That's very clear answer, sir. Thank you very much. Yeah.
Thank you. Thank
How
you.
about another question, please? I mean,
Yes, please.
about human digestion system. Do you think for a long term, if we consume those very small particles of food, it would be like absorbed into our body system really fast? In the long run, are there any like medical research, like towards that development of food within when humans consuming it? Are there any like medical research on that, sir?
Yeah, for when you are considering as you are asking about when you are making is a nano encapsulated nanoparticle, whether any medical research is going on. Am I right?
Yep.
Yeah. Yes, exactly. It's a lot of research are already is going on, because when you are preparing as a nanoparticle, we can deliver in some particular targeted site. For example, you have some injury, or you wanted to have some purpose in delivering in the intestine, small intestine. You no need to deliver that compound or some that biotic compound or nutrient in your mouth or stomach. It has to be the intestine. This nano encapsulation can be used as a vehicle form. We can make as a capsulation, a vehicle form, and we can deliver in particular place. For that, they have done for the green tea, and they have also used a grape extract like a resveratrol for cancer prevention, and they also used curcumin from the turmeric. They are used and they have delivered, and even they wanted to cure the diseases. They wanted to prevent the cancer, and so many things they have been used, sir. Already this kind of work is going on, so widely is going on, and they have given a good result. That's what people are started to use. Especially you can also see in the Horlicks. I given one example, Horlicks. It is given from the Hindustan Unilever Limited, and they have make it as a fish oil DHA encapsulation, and they have put it in the powder form. When the pregnant woman is taken from the 4th month itself, and they are getting the baby neuron development, eye development, and brain cells development. It is highly helpful. So they use this nano encapsulation technology as a tool to deliver the compound. So the widely people are now started to use, and some product already in market.
Very good. Thank you very much, sir. Very, very clear.
Thank you, sir.
And very good idea too. Yeah. Yep.
Thank you, Professor.
Thank you, Dr. Song, for that wonderful question. And thank you, Dr. Karthik, for responding so amazingly well to his. And I think it was a very detailed explanation what you've given him. So are there any other questions? Would anyone else like to ask any other doubts? All right. I think if there are any other questions, you can ask it in the chat box, and we can always revisit it later as well. So if any of you have any questions, please park it for later. And Dr. Karthik Pothiappan, again, once again, thank you so much for giving us a wonderful session today. And on that note, we would like to move on to our next keynote speaker, who's Dr. Songpol Boonsawat. He is currently working as a head of research, design and development, Rigertech, Malaysia. Researcher and a technological expert with the United Nations Economic and Social Commission for Asia and the Pacific. Dr. Songpol, I would like to welcome you to our wonderful session today, and I'm sure that your knowledge and the kind of deliverables that you would be able to give us would create a large impact on our audience as well as with our participants today. Dr. Song, it is your turn, and the floor is all yours. Thank you.
Okay. Thank you very much for having me today. Thank you very much for the invitation as well. I feel really lucky to be, in this webinar today. Today, I'm going to speak about the plastic pollution fact in the water resources, because it's World Water Day, right? So actually, I'm specialized in solving global plastic waste problems. And my name is Salbud. In order to, before we discuss more about this, I would like to make it clear on the statement that we would like to do or making the impossible and make it possible. So since we have seen the plastic waste has been around us everywhere around the world. Right now, I'm moving like several countries. and I'm trying to solve the plastic waste problem. Now I'm in US. Um, in order to solving global plastic waste problem, I would like to introduce you to today's plastic waste problem first. Now today, why application of plastic result in plastic waste being um, present in the water environment and also in the soil or in everywhere, because we have been using it in wide variety of sizes in many industries. Plastic waste are in water mainly as microplastics. It's floating in the ocean as well. The size range up from 1 nanometer and up to like probably less than 5 millimeters. So microplastic has been known and has been recognized as the emerging threat and issue into the globe, as well as the ecotoxicological and ecological risk for water ecosystem, including ocean and freshwater resources as well. So in this presentation, I would like to just review and present some of the physical chemical properties of plastics materials and how to determine as the toxic effect on the aquatic environment. And I'm gonna answer like the most popular question: why today is still plastic waste? Why today plastic waste still a problem? So as mentioned, one of the main sources of microplastics introduced into the fresh water and the rivers and also the ocean are the pathway for the transportation of the pollutant to the sea and oceans. It creates lots of pollution because two reasons. One, we don't have a proper waste disposal treatment to take care of it. And second thing is that the word that we've been using, reuse, reduce, recycle, whatever, we said it too much, but it haven't been happening. It have never reached like more than 15% on average. So let's say the 85% most likely go straight to the landfill, or probably go to end up in the improper waste disposal treatment, or probably end up in the water resources or in the ocean. So I would say the numbers is quite scary because it's since 1950s. We were starting with 1.5 tons per year only in plastic waste production, but today, as measured, it's more than 300 million tons per year, because the plastic waste, the plastic material itself is really good material. It's drive economic going up crazy, but it also pull the environmental down to the let's say to the ocean or to the lowest part of the ecosystem, whatever, right? So the issue is the discharge of reduction of plastic pollutant into the water environment needs activity in the scope of efficient wastewater treatment, waste disposal treatment, recycling of plastic waste material, and also educational and public policy involvement. So all these 4 or 5 um, 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 parties or stakeholders, all these 4 or 5 criteria or list I just list down, it has to be involved. So let me show you just one single video that will tell you everything, how toxic it is and how it's gonna be. Oh, sorry. This is plastic life cycle. We did this video probably 3 years ago. Quite interesting. There's no proper solution for it. Just come back to us. Oh, thank you. So the introduction about this video is just want to introduce you to the plastic waste problem with the water resources. The production and distribution of the plastic continue to increase both in developed and developing countries. From the 1950s, the plastic production increased almost 200 times towards this day. It started from 1.5 million tons per year until now. It's up to more than 300 tons per year in 2017 already. Plastic, they are all lightweight, heavy, highly durable, heavy duty, strong, and cheap. While it's driving like economic growth really fast for every nation. Everybody likes it, but the environmental falling down because we don't have any proper waste disposal treatment for it. My idea is to saying that we can solve this problem, we can make it possible. It's not just saying that we use recycle. It doesn't work that way. I mean, if we have a proper technology to close this loop of plastic materials or products after it ends of life, it doesn't matter how popular it is. You want to use it, you keep using it, it's okay. As long as you know how to dispose it effectively, like converting into something else more valuable that can be sold back to the market, still keep the economic growing up, or reduce the use of fresh raw material, dispose it effectively. Like for example, I'm working on the thermal conversion process to convert plastic waste into fuel to maximize the benefit of the plastic waste, which we harvesting from the landfill which already exist, or we gathered all those free plastic from the ocean. So I would say they are used in a great number in applications ranging from household personal goods, clothing, packaging, until like towards construction material, in everything, everywhere. They are all involved in plastic. I believe so that today you already use some of the plastic material yourself. Even myself, for example, an average, everyone in globally, anyone been producing any type of plastic like 200 grams at least per day. A food container, a product, anything like near your hands, all made from plastic. I can believe I can prove that. The deep research telling that plastic once itself occurs in the environment, it will become microplastic. The previous video showed that end of the loop, it goes to animal, fish, or some sort of something that we have to consume. Thanks to Dr. Karthik, that he answers fully answers on the question that I asked from his previous presentation about what would be later on if the food or anything else is going to towards that nano scale. He already answers that it's going to be going into our body system, and later on anything that's smaller than micro, which is, let's say, plastics start from micro. If we leave it like that, it's going to be nano for sure one day, let's say for another probably 100 years. And later on, the fish eating it or anything else, some animal consume it, digest it, we eat the animal or we consume the plant or something like that. All those toxicant elements or additives that the manufacturer has been put into that plastic granule, it's going to go into our body system. So imagine that, right? Microplastic by design, or a result from degradation, larger plastic waste. It could be like one major aspect of the plastic pollutant is the occurrence of microplastic in aquatic ecosystem. Right now, it's really happening, but we just don't feel it yet. That's all. We've seen plastic waste end up in landfill a lot everywhere I travel. There must be plastic in the landfill. Of course, why? We don't have a proper solution for it. We cannot burn it. We burn it. We create like toxicant gases. We bury it in the landfill. It will stay there for another 450 years. So no choices. I mean, we use it. If it's dirty, are you going to use it? No, nobody's going to use it. If the plastic material is dirty, are they going to recycle it? No, they're not going to recycle it because the cost of cleaning it up is more expensive than produce the plastic from the fresh granule. So it has to be involvement among those parties I mentioned earlier. It was estimated that the accumulative potential of plastics in marine environment will be the range of 200 million tons in the next 3 years. Okay, so every drop, let's say why plastic waste is problem in our water, right? Every drop of water that will ever exist on our planet is already at risk because there is some plastic has been accumulated for at least right now, let's say 72 years. We never have any proper waste disposal on it. We burn it. We create toxicant gas at PM 2.5 and whatever. Plastic, which takes decades or I think at least average 450 years to decompose. So when it decomposes, when it goes, I mean, decomposed, it becomes microplastic, nanoplastic, and then later on, if it goes into plants, if it go into living cells, whatever, and then we consume it, it's gonna go to our body system, as I said. So poses a threat to our water supplies and water quality in varieties of ways. So later on, probably we probably won't be able to drink the water from the tap anymore because we will be scared if they use the nanoparticle of those plastic or microparticles of plastic from the water tap or the water resources. So the discarded plastic bags from our throwaway or let's say I will use the word like one-time use, the single use plastic will be thrown away in society, end up blocking storm drain and covers, impeding the flow of water and worsening the bank erosion. On the other side, I said I have some bullet points saying that the best solution is to close the loop of the plastic waste material. It's the only way, really. We have tried. to avoid plastic by bringing reusable bag to grocery store. We use them like multiple times, using those plastic bottles, switch from disposal to reusable drinking bottle. Does it help? I don't see it help at all because the percentage is still quite low. The only things that there are only two choices. If you want to use it, we have to dispose it properly. If we don't want to use it, stop using it and ban all plastic. Stop producing it. That's the only way that we can get out of this game. So it will never happen. So let's go back to the possible way that we can do. It's just to bring up the proper technology, implement it as much as we can, and adopt it into real life. Okay. I mentioned at the very end saying that, but in the real life, can we really make this happen? Reduce? Can we reuse? Can we recycle all the time? No. I'll give you some example. Recycle plastic materials can be recycled up to 5 to 7 times only. The chemical bonding is not, it won't be good at all times. So if you recycle too much, it won't be any good anymore. So at the end of the walkway, you still have to find a proper solution to do it. If you think there was a guy, a very smart guy from MIT come to me saying that we want to recycle or recover those plastic waste material to do like, brick, to build a house. It's lightweight brick. And then I was in the TED Talk, TEDx in MIT, and I was just asking them, what about if your house breaks down, or after 30 years you want to renovate the house? What are you going to do with the material? You break it down already. Are you going to recycle it? There's no way to recycle it. So it has to end up in some sort of landfill. So what was the point? Because you not create the waste now, you reuse it, okay, but end of the walkway for another 30 years. What are you going to do actually? He doesn't have answers, so which is mean that it has to go straight to landfill still, right? Next. Oops, okay. Plastic also leaches into the water, degrading the water quality with toxic compounds and end up harming humans and animal health. Of course, plastic pollution from discarded waste bottle, polyethylene coffee cups, blah, 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 anything, the clothing that made from plastic as well, anything once it break, the waste break down into tiny bits of plastic. It's no bigger than the periods at the end of this sentence. So nothing that we can see from our own eyes it will be exist for another like at least hundreds of years. So we don't have the deep research on that yet. So microplastics have been detected in the water around the world currently, including our stream, rivers, lakes, and oceans. In the waterways, the microplastic end up in water we drink, see, and the fish eat it, we eat, including shellfish. I just show you the video that we did like 4 years ago, and then it's really happened that way. And I didn't wish that I was the person eating that fish, but how could I know that the fish already consumed this kind of plastic? So nobody knows, right? Wildlife is harmed. So the nature is like being threatened when plastic is tangled in limb, neck, or other body parts. Let's say 2-3 years ago, I saw a plastic straw was in the sea turtle's nose, and it didn't look good, and then it's really harmful to wildlife and ocean. This is often mistake plastic for food. It's single-use plastic, which is not really good design. This day we reduce it, but it's still nothing can compete the plastic material because it's really, it's really competitive in the economic world. So nobody's like really wants to be like to be really serious about it. We said these were too much, but we never need it, but not enough. Reduce, reuse, recycle. The last review in November 2020, 2021, I did a list of the last review of the plastics situation around the globe right now. It's like over 300 million tons of plastic are produced every year. 85% goes straight to those improper destination. So it was produced for use in wide variety of applications as well. At least 14 million tons of plastic end up in the ocean and rivers. 14 million tons with the 3 zeros every year end up in ocean and water resources. And plastic make up to 80% of marine debris found from surface water to deep sea sediments. As you can see from the video that I just showed you, marine species digest or are entangled with plastic debris. So they can digest it actually, which causes severe injuries to and death. Some of them can, some of them cannot. Plastic pollution threatens food safety and quality human health. Coastal tourism contribute to climate change. All negative impact is coming from these plastic, right? So there is an urgent need to explore new existing legally binding agreements from the public policy perspective, or explore new existing technologies, which is I believe so is currently available. But I have been trying for many years. I say this way. I don't want to sell too much of the technology part, but I just want to bring up like how can we solve this plastic waste problem globally. I would say that the plastic is a synthetic organic polymer, so it's made from petroleum-based chemical. There is so many ways we can use chemical engineering just to solve this problem very easy. I will show you from into the next slide. I mean, tomorrow will be more plastic. Why do I say tomorrow will be more plastic, and more plastic waste problem will be more? Why? These two words. Tomorrow will be more plastic, and also more plastic waste will be the problems too. Why? Because the population keep growing up. We don't have solution, a proper one for it. If we just stack up a pile, last year at least I think 50 to 100 landfills itself for just for Asia Pacific has been filled, and it's already been full. 50 to 100 landfills in Southeast Asia alone has been filled up, and it's already been full of plastic, and it has to be full like that for another at least like 400, 500 years. Next 5 generations, we still have facing this problem. We won't get out of this problem until we use the proper waste disposal treatment. Some people, let's say 10 years ago, saying that just burn it. We have a safe, system that can burn it and get energy out of it. It's maximize utilization. It's good, but actually, no, it's not, because plastic wasn't designed for burning. You burn it, it doesn't matter how good treatment you're having, it still create toxic gases. You just treat that gases and try toxic gases and try to get it and try to neutralize it. Like you try to make it as safe as it can, but it's a toxic gases. Remember the word toxic. Once it's been toxic, it's been toxic. It doesn't mean like less amount or large amount. It's still toxic. It's a toxic. So yeah. So okay. So why plastic problem is in our water? I already mentioned about this, but plastic is less than 5 millimeters, and their negative health impact have been studied in ocean, rivers, and even soil, which is like in the landfill. Scientists are beginning to grapple with human health impact that presents might have one under studies, but critical link in this cycle is groundwater, so which is often a source of drinking water in some area. So why microplastic in groundwater likely to affect man's health? Only a handful of studies that have been examined that the abundance and the movement of microplastic in groundwater. This gap means the potential for adverse health and effects remain largely unknown. We don't have any numbers for sure. Why plastic waste problem? For the kids, I said we don't have a waste disposal, a proper one, technically used for where we have been really popular and widely used right now is primitive. It's what's designed for something else. For example, landfilling. What do you use for? You use for uh, putting those organic waste like food waste, animal bodies, whatever, like something that can degrade. We can put underground, right? It's acceptable. What about incineration? What is incineration was designing for? It was designed 50 years ago, used for medical waste only, something that could affect us like by disease, whatever. We have to burn it. We have to destroy by burning. So it's acceptable. But combine those two, it's very popular using right now, even in your own country right now, in India, Philippines, wherever, these two still currently used. So I don't see anything like proper as a proper waste disposal treatment at all. I've been working on this field for more than 10 years. So the lack of technology implementation and enhancement for a serious problem solving solution of plastic waste, it's not been implemented yet. I see. Proper behavior pre-or were supporting accumulation of waste worldwide because, as I said, it's growing very good economic for every nation, but it's pulling down the environmental quality in every nation as well. So okay, it is um it is still problem. Yeah, still has a problem. It will be still problem. Yeah. Landfilling, I said already, high popularity, suitable for organic waste only, not suitable for plastic. Create secondary pollution, reduce living space. So if we can harvesting it and convert it to something that really valuable, it could solve the problems that close the loop. Incineration as well, high popularity everywhere having it, suitable for clinical and hospital waste only, not suitable for plastic. It creates toxic gases when it's burned. So the only way that we can solve this one is finding a proper plastic waste disposal treatment. I would just make a conclusion on this: the implementation of a proper waste disposal treatment. I've been doing research, and then this is a key gap that we seek us to reach out. What would be the best possible proper waste disposal technology for plastic waste alone? What are the requirements? It's a question. What are the requirements of proper waste disposal treatment for plastic materials? First one, it won't degrade. We have to find something that can degrade it, which is like the only available will be thermal degradation technology. Thermal degradation technology, it has to be a special one because it cannot be burned. So no ignition involved, no burning during the conversion process. So it will ensure that no toxic gases will be created during that time. No oxygen participation, no toxic gases happen. So recovery process, we call it, because it's not reduced, it's not reduction, it's not reused, it's not recycled, it's called recovery because it's maximize, it aims to maximize material utilization of the product or the material. And we can consider that as a secondary resources. This is the only thing that I can think of right now. For the past 5 or 10 years, I've been working on it. The only thing that we can do, as long as we use it, it has a nickname called pyrolysis. As long as we control the process well, process plastic waste with the absence of oxygen, so preventing from the burning, the process reduce risk of toxic gases formation. We have to close the system when it's processing, meaning that there is no leakage, there is no contribution of or participation of any oxygen involved. It will be heat up. If we create gases, we can convert the plastic waste material into petroleum-based gas first, and then we condense it into fuel oil, diesel, gasoline, or usable gases for designed process. Okay, recovering rate approximately like 80%. Wow, it looks quite good. We don't create that much of the toxic gases, whatever. We can still have 80% recovering rate by weight of the input. So which just means you put in 1 ton of it, we can create at least 800 kilograms of the product at, as byproduct, and it can be sold back to the market too. Energy consumption rate is controllable. It has to be smart technology. We use AI contribution. It's less or next to the zero emission level. Controllable output product formation and their quality by smart technology or AI. So we say that this will close the loop, and it is the best right now possible practice that we could completely solve plastic waste problem. I thank you very much for your presentation. If you guys have any questions, please let me know. Thank you. Any question, please?
Thank you, Doctor, for the wonderful session. And I would like to open the floor for any questions available from the audience. You can verbally ask your questions or type it out in the chat box. Yes. Could we have any queries? All right. I believe that if any of you have any questions, then you could always email it to the email that our doctor has put up in the chat box. You could always put it up to him, and I'm sure he would be more than happy to answer any of your questions through email.
You have any contribution, any project involvement, anything? I would love to support. So anything, so we can start discuss. I'm okay. Thank you very much. I'm having projects up in India very soon too. If anybody wants to have more, please contact me.
It's okay. All right, everyone. I believe that at the start of our session, we had informed you that we would be having 3 keynote speakers today. But unfortunately, we have received word at the last minute that our third speaker for today, Mr. Nimal Raghavan, has been unable to join us due to personal reasons. And we hope that everything is well on his side, and we would be hoping for his best recovery as well in that. And on that note, I would like to wind up today's webinar session with a vote of thanks to our 2 wonderful speakers, Dr. Karthik Pothiyappan and Dr. Songpol Bunswat. So thank you so much for your contribution to this World Water Day. It was really informative, the topics, and it was very knowledgeable as well. I'm sure the participants and the knowledge and all the students and everyone, all the delegates who have joined us would be very much aware of these technology and of these facts that have been dispensed today in the session. And on that note, I would like to, and on behalf of USFN and the organizer, I would like to thank each and every one of you, the speakers, delegates, and the audience for your participation, energy, and time today. We all appreciate your contribution to today's session. And thank you all for participating in our webinar. Also, I'd like to inform you that please do stay tuned with us for more updates regarding the USFN webinar and conferences that are yet to happen. I would like to share my screen with you all so that you can look at the link where you can download your e-certificate from the USFN dashboard. Let me just share my screen with you. All right, sharing my screen. As you can see, we have put up the contact information for USFN on the screen for you, and also the two people who can be who can be communicated in regard to USFN, as well as the certificate link where you can download your USFN certificates for the webinar. Let me post the link as well in the chat box as well, as many of you have requested it. I have posted the link in the chat box as well for ease of access. Thank you to everyone for your feedback on the session. I believe that everyone has been able to access the link and have been able to download your certificates in that. So once again, thank you for joining us on this webinar on World Water Day. I'm sure after this and even before this, I hope everyone has been saving water, and let's make sure that there is water for the next generation and for many more generations to come. Let us be very mindful about our water usage, and let us make sure that we are very precious with the most precious thing on earth, which is literally something that is very needed for our everyday life, and it is life making ingredient is what I would like to call it as. Thank you everyone, thanks for joining us today, and I hope everyone has a very good day today. Thank you.